All right, in this video, we're going to be looking at determinants and how to calculate determinants from matrices. So every square matrix, now when we talk about a square matrix, we are saying that they have the same, we're looking at an m by m. So they have the same number of rows and the same number of columns. So any square matrix has a real number called its determinant. The determinant of a matrix A is denoted as the det of A, or we'll see it as almost like, it looks kind of like the absolute value of A, but it's called the determinant of A when we're talking about matrices. The determinant of a 2 by 2 matrix is called a second order determinant. To find the determinant of a 2 by 2 matrix, we want to use the following rule. So given, let's assume that this is A, where every element is given by A, B, C, D. Then we know that the determinant of A is going to equal A times D minus C times B. In other words, we are taking the diagonals and multiplying them together, and then we are adding the diagonals together. So there's our AD, and then there's our BC, and then we're going to subtract them. Sorry, I said adding. We're going to subtract them from each other. So this is how we calculate the determinant. All right, let's take a look at a couple examples. So find each of the determinants below. So we're going to take these two diagonals. So I get -4 and 10. So in this case, if we called this the determinant of A, this would be -4 times -10 minus 5 times 3. So that would give us +40 minus 15, which is a total of 25. So the determinant would be 25. We should be getting just a single value, not another matrix here. So in calculating this determinant, we're going to go, again, the diagonal. -6 times -2. That gives me a +12. And then I have 11 times -3. And that's going to be minus -33, which gives me a determinant of 45. Number 3, here, we're going to take 5 and -9. And so that's going to give us a -45. And then we're going to look at -5 and -7. And that's going to give us a minus a +35. So that's going to give us a -80 as the determinant. 2 times -8, that gives us -16. 4 times 2, that gives us a +24. We add those together, we get a -40. Right? So that's how we calculate the determinant. The determinant of a 3 by 3 matrix, this is called the third order determinant. To find the determinant of a 3 by 3 matrix, we want to use the following steps. We're going to rewrite the first two columns to the right of the matrix. Okay, so in this particular example, let's see if we can do the example at the same time. We're going to take the first two columns. Here's our first column, and I'm going to write it over here. So I'm going to have 3, -5, 1. And then we're going to take that next column, and we're going to write it out, -7, 4, 5. We're going to find the sum of the products of each downward diagonal. So we're going to do the downward diagonals. Let's pick a specific color for this. Let's do blue. So we're going to do the downward diagonals in blue. So when we calculate this, notice I'm going to go like this. So I'm going to have 3 times 4 times -1. Okay. So this is going to give me a -12. And then I'm going to have my next diagonal is this one right here. And so now I'm going to have -7, -5, 1. And that's going to give me a +35. And my third diagonal is right here. And so 2 times negative 5 times 5, that's going to give me a negative 50. So now the sum of these, I'm going to add all these together. So negative 12 plus 35 minus 50, that's going to give me a negative 27. So that was the downward. So remember, this is the downward diagonal. I'm going to change colors here. Let's do orange. So now we're going to find the sum of the products of each upward diagonal. So I'm basically finding wherever I can find an upward diagonal, and I'm going to sum those products. So notice that I can go 1, 4, and 2 this way. So 1 times 4 times 2, that gives me 8. 5 times negative 5 times 3, multiply that out, and then we get negative 75. And lastly, I have negative 1 times negative 5 times 7. And this is going to equal negative 35. Again, we want to sum these diagonals here. And this is going to give me a sum of negative 102. So once I have remember, this is the upward diagonal. Once I have the downward and the upward diagonal, what we're going to do is we're going to subtract the upward diagonal from the downward diagonal sum. So my upward diagonal was negative 102. Oh, sorry, I'm subtracting from, sorry. So I have to read this carefully. So we're going to subtract upward diagonal from the downward diagonal. So my downward diagonal is negative 27 minus negative 102. And so this gives me a total of positive 75. So the determinant of a 3 by 3 matrix, right? Again, we're going to have to sum the downward diagonals, the upward diagonals, and then we subtract the upward diagonal from the downward diagonal. So this translates to our downward minus the upward diagonal. Okay? So that's what's happening here, and that's how we get that 75. All right. Let's try a couple just to make sure that we got a good hang of it. And then I'm going to have you try some of them on your own as well, just to ensure that we got it. So here, the very first step again is we're going to take the first two columns and rewrite them. So we're going to have 6, negative 1, negative 3, negative 3, 4, negative 6. What's the next step? You guessed it. We're going to do our downward diagonals. So we're going to have 6 times 4 times negative 4. And then that's going to give us 6 times 4, and then we multiply that by a negative 4. That's going to give us a negative 94. Then we're going to do the next value, which is negative 3 times 2 times negative 3. This diagonal. And so that's going to give us a positive 18. And then lastly, we have this diagonal, 6 times negative 1 times negative 6. It's going to give us a positive 36. So let's sum these up. Negative 94 plus 18 plus 36. This gives me a negative 42. Now, let's go ahead and calculate those upward diagonals. So we have negative 3 times 4 times 6. And that's going to give us a negative 74. Plus, now we have negative 6 times 2 times 6. That's going to give us a negative 72. And lastly, we have 4 times negative 3 times negative 1, which will give me a negative 12. All right, so negative 74 plus negative 72 minus 12, that's going to give us negative 156. So again, remember, we're going to do the downward minus the upward. So we're going to have negative 42 minus the negative, or minus 156. So we're left with, it's going to be minus, minus negative. So it should be positive. And so we end up with a positive 114. Let me make sure that this is clear. So I'm subtracting the upward, which was negative. There you go. All right, go ahead and pause the video here and try the next one. All right, so take a second to review your answer. Did you get negative 148 for the downward diagonal? And did you get negative 110 for the upward diagonal? In subtracting those two, did you get negative 38 as the determinant? Okay. Should have been the determinant. Now, the next one is going to be very similar to what we just did. So if you got that right, let's try out the next one. Go ahead and pause the video. Try this one out, and we'll see if you got it. All right, check your answer. Did you get this for the next one, right? 3 by 3, write the first two columns first, calculate those diagonals, and then subtract them. All right, so hopefully you're getting the hang of calculating the determinants of matrices. Let's look at an application problem here. So in this application, we're looking at the area of a triangle. So given a triangle with vertices x1, y1, x2, y2, x3, y3, the area of the triangle can be found by using this formula. So we'd have A equals 1/2 the determinant of x, where x is given by this matrix here. Notice that the last column of this matrix is all ones. Okay. So the triangle PQR has vertices -5, -2, 3, 9, R is 7, -4. Find the area of the triangle. Okay. So we want to find the area of the triangle. So the way that we go about doing this is we're going to first build out our matrix. So let's label what our matrix X would be. So our matrix X would compose of x1 followed by y1. So x1 would be -5, y1 would be -2, 1. Then we would have 3, 9, 1. 7, -4, 1. Here's our matrix. Now let's calculate what the area would be. So the area would be equal to 1/2 the determinant of x. So we need to figure out what the determinant of x is. So the determinant of x, let's come down here, would be equal to, and now this is a 3 by 3 system, so we're going to have to write this out. Actually, I changed my mind. Let me write it over here so we have enough space. So the determinant of x is going to equal, and so we're going to have -5, 3, 7, -2, 9, -4, 1, 1, 1. But remember, now we have to write the first two columns again, -5, 3, 7, and then -2, 9, and -4. So let's calculate the downward and then the upward. So when I'm looking at the downward, I'm going to take -5, 9, and 1, multiply those together. That's going to give me a -45. Then I'm going to take -2, 1, and 7. So that's going to give me a -14. Then I'm going to take 1, 3, and -4. And that's going to give me a -12. So -45 minus 14 minus 12, that's going to give me a -71. All right, let's do the upward, and I am going to change colors for the upward. So then our upward would look at 7, 9, and 1. Multiply that out, that gives us a positive 63. Then we have negative 4, 1, and negative 5. That's going to give me a positive 20. And lastly, we have 1, 3, and negative 2. So that's going to give me a minus 6. 63 plus 20 minus 6, that's going to give me a positive 77. So the determinant here is going to be negative 72 minus 77. So that's going to give us a total of negative 148. Okay. Now, because we are calculating area does not make sense in terms of it to be negative. So we are going to take the absolute value of negative 148, and that'll give us positive 148. So now we're going to do 1/2 148 gives us the total area. So 1/2 of 148 is going to give us 74. So that tells us that the area of the triangle, here, let's write it over here. The area of the triangle would be 74 units. (74 units squared. Okay. All right, let's look at the next problem. Wellspring is 14 miles north and 3 miles east of Chester. So if this is Chester right here, if we want to kind of think of this being on a grid, here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And 3 miles to the east, so here's 1, 2, 3. So at 3 and 14, this is where Wellsprings would be. And then lastly, Hilford is 8 miles east and 4 miles. So 8 miles east, so 1, 2, 3, 4, 5, 6, 7, 8. So this is east, north, south, and then west. Okay. So then if we are 8, so here's 1, 2, 3, 4, 5, 6, 7, 8, and 5 miles north. So here's 1, 2, 3, 4, 5. This is where Hilford would be at. And then this is where Chester is at. So we are essentially find the area of the land formed between these two towns. So we are really looking at the area in here. Okay. So let's look at these points. So I purposely made Chester the origin, because that's what everything is orientated to. So Chester would be the point 0, 0. Okay. We would have Wellspring be the point, remember this was 14. So this would be 1, 2, I think it was 3. 3, 14. And then lastly, Hillsford would have been 8, 5. So I always recommend drawing a picture. I think a picture makes all of this a little bit more contextualized in terms of where you're seeing things happen. All right, so here are points. Now let's go ahead and create our matrix. So our matrix then is going to be x1, x2, and then 1. So I'm going to have 0, 0, 1, 8, 5, 1, 3, 14, 1. Does it matter how I wrote the points? No, we'll still kind of, we'll get the same answer. So we need to, so this is our matrix. Let's call this matrix X. Okay, so in order for us to calculate the area, remember that the area is going to be 1/2 the determinant of our matrix X. So let's go ahead and calculate this determinant. So we need to first recopy the first two columns. So now let's go ahead and multiply this through. So I have 0 times 5 times 1, that's going to give me 0. 0 times 1 times 3, that's still going to give me 0. And then I'm left with 1 times 8 times 14, which is going to give me 112. So this is my downward, remember. So now looking at my upward, now we're going up. So then I'm going to have 14, 1, and 0. That's a 0. Then we're going to have 1, 8, and 0. Oh, did I miss one? I did miss one. 3, 5, and 1. That's 15. So our first one should have been 15 plus 14 times 1 times 0, 0. 1 times 8 times 0 is 0. So then we end up with 15. Okay. All right, so now we're going to go ahead and remember, it's going to be our downward minus our upward. So 112 minus 15, right? So it's going to look at 112 minus 15. That's going to give us a total of 97. Okay, so then we know that our area is going to be 1/2 times 97, which was our determinant. And 1/2 times 97, that's going to give us a total of 48.5 square miles. Now, I'm running out of space here, but we really should write this in a sentence. Let me change, let's come over to black real quick just to finish it off. I'm going to go ahead and erase this right here, and let's just finish it off. So, the area formed by the land between these towns would be 48.5 square miles. All right, and that is all for determinants, I believe. What's next? Yep, that's it for determinants.